Hi friends, in this session we will discuss the algorithm analysis. This is the agenda for today's session. These are the topics we will cover in this session. What is the need of analysis and what is the performance analysis? So first question is what is the need of analysis? In the previous lecture I told we will design an algorithm, right, based on the designing steps. We have to design an algorithm, right? Once you have design a particular algorithms for a particular problem, how you can identify your algorithm is good and somebody else algorithm is good, right? As I mentioned earlier, so this is the problem P for which you have designed algorithm A1 and A2. So how you can identify algorithm A1 is good or algorithm A2 is good, right? So that is depends on the analysis. So you will analysis of your algorithms A1 or other algorithms A2, and based on the analysis you can say algorithm A1 or A2 is which one is good, right? Based on the analysis. The question is what is the need of analysis? Okay. So need of analysis basically there is two things is required. So first one is determination of resource consumption. So that is the first important point for which we need of analysis. Okay, understood? So first, if somebody asks what is the analysis, so first point is to determine the resource consumption. And second point, this is the first point. And second point is compare different methods for solving the same problem, as I told, right? For this problem P1, we have two algorithms A1 and A2. So compare different methods for solving the same problems. Okay. So there are 2 points to determine the resource consumption. Resource consumption means CPU time and memory space. Okay. Second point is compare different methods for solving the same problem. That means we have to find the efficient algorithm. So that is the need of analysis. Performance of algorithm can be measured on the scale of time and space. Okay, so for a particular algorithm, if you are talking about the performance, so you have to calculate the time complexity and the space complexity of that particular algorithm. So most of algorithm fall into one of the following type. So basically there are the type of the algorithm complexity. So first one, the algorithm complexity can be logarithmic, that is log to n. So first one is logarithmic algorithm. So if some algorithm comes under this logarithmic, so that is very good, right? Second is linear, that is order of n. Next is order of n square, that is quadratic one. Next is polynomial, that is order of n to k, n to power k, where k is greater than 1. If the value is k greater than 2, that can be poor, right? So basically we are trying to get the algorithm complexity as low as possible. And the last one comes under this exponential. So that is awful, right? So we are not considering this kind of exponential complexity. So we will mostly try for this logarithmic, linear and quadratic. The next question is what is algorithm complexity? So you can say complexity basically is a measure of the performance of an algorithm is called complexity, right? Okay, understood? Complexity means the measure of the performance of an algorithm is called complexity. So as I told earlier, performance means you are talking about the time and the space. Okay. So before that, we will discuss. Uh, so algorithm performance also depends on the two factors, that is internal factors and external factors. So first we will discuss external factors. So external factor means that is impacted externally for your algorithm, right? So externally means first one is the computer, which kind of computer you are using, right? Suppose you have a design algorithm, you have implemented that. Now you are executing that algorithm over a system. Okay. So now depends which kind of system you are using. If you are using latest configuration, right? i7, i9 processor, and same algorithm you are running on dual core or maybe the Pentium processor. So obviously that is the difference between i9 processor and Pentium, right? So the first point is that is your computer, right? Second one is quality of the compiler. Which kind of compiler you are using? You are using the modern compiler, you are using the traditional compiler. So that is also impacted the performance of your algorithm. And the last one is the size of input data. So if you are giving very small input data to your algorithm, that it will take a fraction of time. And if you are using billion of input or trillion of data, then it will take surely some time. So these are the external factors. And in the same way, we have some internal factors. Right? Internal factor means that it depends that is affected your algorithm internally, right? That means the time and the space. So these are two internal factors. Just keep this point. So complexity measures the internal factors, usually more interested in time than space, right? So obviously, I'll consider only the internal factor mostly. And in the internal factor also, we will consider maybe the time and space, but mostly we are focusing on the time than space because in the current scenario we have plenty of spaces available, right? If a particular algorithm is not bounded to the space, so space is not concern for us, right? So we will mostly focus on time than space. These are the image references I have taken, I have used in the algorithms, right? So thank you watching this algorithms complexity part. Okay. If you have any suggestion, any uh, doubt, so you can put your comments and I will reply accordingly. So please like, share and subscribe this channel. Thank you.